Federico, Alexander, hi. I'm really glad to welcome you here, and I see that it's sunny for both of you. And Federico, can you please tell us a little bit about your place in London? Because there are no traveling, and a little bit of news can be a good thing.
Sure thing. Thanks, Vladzilo. So, hi everyone. My name is Federico. I live in London right now, next to the Olympic Park, which is the stadium in London where the Olympic Games took place in 2012. Today is a bit of a sunny day in the city, I would say. We haven't seen the sun in a while. And the other good news is that today is our first day after the end of quarantine. So now we're allowed to go out for restaurants and bars. It's the first day in which restaurants are opening and bars are opening. So I suspect there'll be quite a few people outside tonight celebrating and drinking beer and partying a bit.
Oh, congratulations and take care. Alexander, and what about you?
So about me, so today is sunny weather, so as I said, that's nice. You live, Federica, you live near the Olympic Park, as I understand. So I now near the reconstructed football and hockey stadium that named of the one of the greatest goalkeeper of 20th century, Lev Yashin. So we both near some sport objects. That's I think that's nice.
Yeah, it's an awesome place to be. And I'd like to remind our listeners that they can ask questions in Telegram chat, and we are going to answer them in the end of our talk if there is enough time, and even if there are more questions that we can handle during our talk. There is a discussion zone taking place in Zoom, and you can also find the link somewhere above. So feel free to ask them, and the sooner you ask, the sooner we answer it, but probably in the end of the talk. And if there are no other questions, let's move on to the talk.
Let's move.
Okay, perfect. So let me start the talk right now. We're going to have like a bit of a long session today. This is going to be an hour long. I'm going to introduce you to GCP Cloud Foundations. So we're going to talk about landing zone in GCP. The reality is that there's a lot of companies in the world right now. Some of them are very large, very big enterprises, and they cannot adopt cloud in a naive way. They need to be able to adopt cloud in a structured way, in a way that allows them to assess compliance and security for all their accounts, which means that there's complexity there. Whenever you have complexity, you want to create a way of standardizing the landing zone itself, standardizing the creation of the solution in the cloud in a way that all your projects operate in the same way. This talk will really cover how to do that in GCP. This is not a talk, it's not a basic level talk. So what I do is that I present some of the characteristics of Google Cloud, and some of them are fairly advanced. So you will enter a bit of details of Google Cloud and how it works and what are the requirements around that. There's a whole length session at the end of the session for questions. So if you have any question, feel free to reach out to me at the end of this and we can have a chat. We can also perhaps explore a bit of different parts. So just I think before we start, actually, any of this is worthwhile for us to, introduce myself. So who am I? My name is Federico. I work at Contino as principal consultant. I've been with Contino for the past couple of years. I specialize in cloud architectures, containers, and cloud native software development. Before Contino, I was managing the site reliability engineering team at Curve. Curve is a fintech startup. And before that, I was a software delivery function in Funambul, which is a company that works with large telcos in the world. So I've worked with Google Cloud for a number of years now, as well as with AWS and a bit of Azure as well for the past years. I have a lot of experience with cloud and cloud architectures. This is why I'm talking with you about this. And the company I'm working for, Contino, is a leading transformation company, effectively. Contino has worked with some of the largest enterprises in the world. We started in 2014, so the company is fairly recent. We've opened offices globally. We have offices in the US, in Asia Pacific as well, and we are now 400 people strong. we worked with more than 300 companies, and they all have one thing in common. They are large, regulated enterprises. So we're working mostly in the financial sector as well as the government sector. So we are helping these large enterprises either migrating to cloud or opening their multi-cloud environments. So a lot of our customers, in fact, most of our customers will at least have a small presence in all the major cloud providers. At this point, we're not in the early stages of cloud adoption. Most companies, most large companies have started adopting cloud, and they have a presence across multiple cloud providers for sure, and we're helping them consolidating this presence. So let's look at the agenda a bit. So I'm going to introduce you to the concept of a landing zone. I'm going to try to explain what a landing zone is and how it looks like and why we need landing zones, right? It's a very important concept. We're also going to look at the structure of the landing zone itself. So we're going to look at how landing zones operate and what is the different components of a landing zone that we need. And then at the end, we're going to talk about operating model. Operating model means how we're going to operate this presence in the cloud. How are we going to do that? How are we going to connect all our different components into GCP, into the cloud? And this is really the key one takeaway. We'll walk you through that at the end. Just one thing to take away is that you need to think about your structure in the cloud, but also your processes, how your company needs to change to support cloud adoption in the best way. So let's take a look at this together. As we said, why do you need cloud foundations? This is the key thing. Why do you need that? Well, you need cloud foundations because sometimes large enterprises will adopt cloud in a naive way. They will start with like a small team doing something somewhere. They will move to a different team. They will do something somewhere else. And then a third team. They will adopt the same cloud provider in a slightly different way. This creates what is called a project sprawl. So this creates an environment in which a lot of different projects have different security standards, different compliance postures. And there's not a way for the company to ensure that what they're doing in cloud is done in the right way. If you want to imagine this sounds like a company that has a lot of small data centers, and each one of these data centers is built in a slightly different way. It has slightly different doors. It's secure in a slightly different way. You cannot enforce any form of compliance. You cannot enforce any form of control out of this. And for this reason, it's very important to create a standardized solution in cloud that enables this level of cloud adoption, I think. It's super important. So our solution, the solution that we built in my company altogether, is based on the 5 pillars of Google Cloud Architecture Framework principles. So we're looking at the best practices of Google Cloud, and we're trying to take those best practices in a way that enables us to really look at what the core features of Cloud Foundations are. It's a super important thing. We're looking at reliability, we're looking at performance and cost optimization, we're looking at operational excellence. We want to make sure that the work that we've done there is the work that we want to do effectively, right? We want to make sure that we don't create a solution that is completely different from Google Cloud best practices. So let's go back at so we said, okay, we need to build a landing zone, we need to build cloud foundations. But there really is a way for the company to adopt cloud. And each company is slightly different. Not all the companies look alike. Not all companies look alike, for sure. Each company is slightly different. And because each company is slightly different, we need to be able to help those companies moving. We need to be able to create a structured way in which we have a core set of principles with billing, resource deployment, security as well. All these core components are required for every company out there. So we create these core components, and then we plug in different modules, adapting them to the specific company that can be plugged in. So maybe not all companies will want to have Google Kubernetes Engine. Not all companies want to run GK. Some of them will. Not all companies will need to have URL filtering in their environment. Some of them will. So our solution is a core set of principles, core set of code, and then we have a number of modules that plug into this code and are connected to that. This is why we have a solution that can accelerate cloud adoption, and it's very important. So when we're looking at GitHub, we're looking at really the solution in GitHub, when we're looking at what is available in the space. I have to admit that AWS and Azure will have way more mature approach to this. AWS and Azure have been working for years with large enterprises, and they created solutions for those enterprises. GCP has not been as mature as them. GCP has started a bit later down the line and has created a number of different solutions to this. You can see that those solutions are on GitHub, are available to be used, but their level of, and they're open source as well, right? So you can go there today and check it out. The level of sophistication of these solutions as of today is not ready for large enterprises. They are in the early stages. They can be used as a basis. This is what we did as well, but they cannot be used as they are now. They're just too naive. It's too early stages. For sure, they will evolve, but you're more than welcome to go check them out, especially the Terraform Example Foundation and the Google Cloud Foundation Toolkit, which are about Google Cloud Platform Zone GitHub repo. We built our solution on top of that, and then we added some components. You're more than welcome to check out what are our components, what we added, and then if you want to add that yourself and think about how you can adopt cloud in your companies, following some of the best practices, what to worry about when adopting cloud in your company. Okay, perfect. So let's start talking about organizational structure. I think this is a very important point. So organizational structure is the way in which we structure our projects on our solution in cloud. So GCP has a pretty standard tiered approach. So each company will have one organization resource in Google Cloud, the one that you see on the top. Then we have folders. Each folder contains a number of projects. Folders are the second tier organizational structure and allow us to establish boundaries. So what do? We have a way to implement policies and processes and controls that we can apply in a top-down, inherited way, in a way that a policy is applied at the organizational level and then trickles down at the folders and at the project level as well. It's a key point of cloud adoption as well, for sure. So when we're looking at this, this is going to enter a bit of the details, right? So not all companies are built in the same way. If you're looking at this, we said folders are a collection of projects, and projects are the autonomous components. Each team in your company will have one or multiple projects. These projects are organized in folders, such as you have a folder for all your development projects in the company, folder for all your production projects in the company. This is the basic solution. It's also what Google presents in their own Google Cloud Platform solution. The challenge is that in companies, if you think about this, if you have a company with 20,000 employees that employs 5,000 developers, it's very unlikely that all those 5,000 developers will operate in the same way. They will operate in slightly different ways. And it's important for you to create a structure in the cloud that maps the organizational capabilities of this developer on premises. This is why we have different folders there. In the same way, we need to look at a number of shared services. If you're looking on the left of the diagram, we have Cloud Interconnect, DNS Hub, and notifications, which effectively mean the way in which we organize our network, the way in which we resolve DNS, and the way in which we manage secrets and notify of security events, effectively. These are shared services. You don't need to have one different way of doing login for each one of your projects. You can consolidate the way in which you manage login, the way in which you manage secrets into these shared services. And then from the shared services, you can move on and offer this into your teams. It's a core change from what is happening on premises. So the big deal here is that you start creating a platform in Google Cloud that enables your own company to serve your own needs. This is pretty standard. And we'll see that when we enter the different details of networking and the organizational structure. So why do we do this? We do this because we need to make sure that all the projects in our company have the same security posture. We do not want to have a project that has a Google Cloud Storage bucket that is left unsecure and nobody knows about. We want to have a single pane of glass to looking at security as a whole and be able to make sure that even if we give autonomy to our teams, this autonomy does not translate into a security risk for the company. This is super important. So this is why we're using a cloud native service, such as organization policies, which are a way for the company to adopt a series of standardized policies. Those policies are, for example, you cannot create a firewall that allows connectivity from all the IP addresses, or you cannot create a bucket that is public to the entire world unless you put some security control. You cannot create a VM without a password. You cannot create a VM without the right level of SSH credentials, right? So you can ensure that if you specify this as an organization policy at the folder level, you can ensure that no one of your projects can breach this policy. They all need to be compliant with the policy, which means that you federating compliance and you're allowing your team to be fast at developing. They don't have to ask permission because they're already put in check by organizational policies. Super important point. And you can see here that, as I said, we have a hierarchical evaluation, right? So they're additive in nature, which means I can say that nobody in the company as a whole can create a bucket that is public in our production network, connected to a production network. And I can specify this as a prod folder. Or maybe I can say that nobody in the company as a whole, anywhere, production and dev, can open a VM without SSH keys in place. And I can specify that on top. I can say, if you're managing your secrets, you should manage them in this way or that way. And this is super important as well. So this is how we have an organization policy hierarchical evaluation. We make sure that we specify one policy at one level, it then trickles down. Okay, so resource deployment. So resource deployment is a way of ensuring that we create our cloud foundations in the right way. So the thing is, I've introduced you to the idea of a need of a platform team. I said, okay, so you have a big company, you have a big enterprise. In this big enterprise, you want to create a platform team. It's a team that will own cloud for all the other teams and will offer adoption of cloud to other teams. This is a team that owns this shared services component. But what happens when I have a small team that needs to create a small application? Maybe I have my platform team in Russia, and I have a small team that needs to create a small application based in London. So what happens? This small team needs to reach out to the platform team in Russia and says, hey, folks, can you create a project for me? This platform team will need to create a project, and the way in which it creates a project is also by ensuring that this project is connected to the right network, has the right type of security in place, is the right type of API in place. So we need to make sure that this is the case. For us to be able to do this, we need to seed the cloud foundations. We need to start creating our cloud foundations. It's a chicken and egg problem, right? So the first step is creating the cloud foundations in cloud. And we do that through some of the automation that you can see is available in the GitHub profile for GCP, or you can have some additional automation on that. But the idea is that you need to start. In most cases, you start from a template, and then you start with a project factory, the project vending. So your UK-based team goes to the platform team in Russia and says, can you share with me a project factory? Can you share with me a vending? And that team does it. So this enables us to talk about something which is called a project factory. This responds to the need of, I have a lot of multiple teams that adopt cloud at the same time. I need to make sure that they are adopting that in the right way. It's a key point. I need to say as well that project creation is this repetitive task. Your platform team does not manually provision projects. Your platform team creates automation that provisions projects. It's a key change from what it was before. The platform team in cloud is not a system administrator team. We're not looking at manually clicking 5 times. We're not looking at manually deploying manual scripts that do things. No. We're doing automation. We're enable self-serving. We're enable speed, effectively. In a lot of companies, I usually see this hidden behind a self-service portal. So the UK team would go to a self-service portal, say, give me a project, Some automation will be enabled, be activated, and a few minutes later, day later, depending on the process, requester will receive an email saying, your project is ready, these are the credentials, you can connect to cloud, you can start deploying, you can start doing things. Behind the scenes, your platform team has created an automation that provides a project, Google Cloud project, provides, and in this project is configured with the right level of security, compliance, and network connectivity. All the bases are there for your project to be secure, right? And to have different controls in place as well on this project. So we have what we call a project factory. Now, how does this work? There's some complexity here, as in most things in life, for sure, there's some complexity here. But let's look at the project vending process. So the project vending process is a process in which we start by creating a GCP project, effectively. And it's an A project, it's not connected with anywhere. So we're attaching this project then to our billing account. We're making sure that this project is paid by the company funds and the right company funds, right? We want to make sure as well they are charged the right or department in the company. We want to make sure that we have the right level of security and access. So perhaps the requester will get a wider set of permissions on the project, and then it will on its own create roles and access for other people in this team. Then we add this project to the compliance services, and we're looking at applying also best practices such as the CIS benchmark. So the CIS benchmark is a series of controls that we will see in a minute that allow us to ensure that logging, configuration, and networking get done correctly. We then attach our project to Security Command Center. So Security Command Center is a single pane of glass, and then we create users and role. So we said, to recap, we have a large enterprise. Large enterprise is a platform team that needs to provision a lot of projects for a lot of small development teams. This platform team automates the creation of the project. And what happens at creation time, the creation of the project is connected with a series of actions in Google Cloud. A series of action means ensuring that the project has the right level of permissions, the right level of access control, the right level of logging, networking, security, threat detection, and the access to the account is provisioned in the right way. Access for humans, right? Humans that need to provision resources in the account. So we can see here that we start having some personas in this project. We have some application users that will need to run their own application, and we have then some platform operators that will need to look after the platform foundations. We can start having also intermediate users. We have service operators that perhaps control databases, VMs, control PubSub, control some managed services. These personas will operate cloud in different ways, and the level of access they need, as well as the way in which they operate cloud, changes. And the solution that we're building in cloud needs to support all of this, right? It's very important. Let's go to an example here. I think is just easier because we're all engineers to understand with an example. So if you're looking at your average continuous integration project, everybody in here now is familiar with this. So we have a source code repo that builds some codes and then deploys codes in different environments, right? You can see this is standard CI/CD pipeline in GCP that leverages cloud native services. If you're looking at this, the left side of this pipeline, the one you see with the red arrows here on the left, source code, build, and test, are typically owned by an application team. Then you have a deploy step, and this deploy step can be owned by a platform team, right? Most cases, if you have a Kubernetes engine and you have one Kubernetes cluster for your entire company that is multi-tenant, that operates a lot of different microservices owned by a lot of different teams, you will have a place in which the application teams write their source code, builds and tests as they want. This becomes packaged into a container that then is deployed on Kubernetes engine. And Kubernetes engine is managed by a platform team. Each one of the resources will have different permissions in the cloud, will operate in a slightly different way. We can see here that the way in which we manage this changes. I can have one Kubernetes cluster for the entire company, or I can have a single Kubernetes cluster for one team. It will become single tenant Kubernetes cluster. And this changes the way in which we adopt cloud as well, in which we're connected with cloud adoption. Okay. And we saw here pretty much the services. So the idea is the way in which we're building infrastructure, we need to treat infrastructure in the same way in which we treat code. So when we have infrastructure changes, we need to create a pipeline that supports these changes. Nothing surprising here. In the same way in which we do pipeline for for the applications, we need to do that same pipeline for our infrastructure. This allows consistency. So we can tell each one of our application teams, you need to deploy a new resource in the cloud. Do that through a CI/CD pipeline, and then the platform team will create policies and practices for you. Okay. Yeah, exactly. So we're talking about entering the world of continuous compliance by leveraging CI/CD products that allow us to create compliant environments. We are able to stay in a green place. We want to start with having at the beginning having everything in a green environment, everything without any risk connected to it. We want a form of continuous compliance, and we enforce continuous compliance with the CI/CD pipelines. Okay, authentication and authorization. So authentication and authorization are very important and is the way in which we manage and we control cloud. Authentication and authorization are used for users and groups. This is both user to machine authentication as well as machine to machine authentication. So how do we do that? For most of you that use GCP, say, well, but there's nothing really complex here, right? So I can create my Google Suite account, my connect there, and I'm fine with that. I can just connect it. Yeah, but in reality, large enterprises will do something more complex than this. We cannot simply just give everybody access, right? So we need to create a structured way. Typically, this is done through Cloud Identity. Cloud Identity is a GCP service that connects not only access to Google Cloud resources, but also connects access to your G Suite account, your Google account. Is the same account you're using on your phone, the same account you're using on your devices. Having a form of cloud identity in place, so a unique repository where all the identities starts to enable something that we will see in a minute. It's called zero trust networking. Starts to enable a very high level of security that changes from the normal level of security we're dealing with. Cloud identity is used to provision access to GCP's APIs, pretty much. So with Cloud Identity, you can obtain a IAM role, and IAM role allows you to perform actions in cloud. IAM role are a way, I'm sure most of the people in the call will be familiar with this. We have this solution in which we have IAM roles that allow access to cloud to users effectively, and they get permissions to that. Large enterprises, though, will not operate in a naive way. You can see here in the diagram that we're looking at a more complex implementation. So we're not looking at creating a G Suite account. We're looking at building a solution that connects with your Active Directory on premises and starts using your Active Directory on premises as a source of users, which then gets synchronized with Google Cloud. There's some complexity in here for sure. But when you're looking at your landing zone in your cloud foundations in GCP, it's super important to have a secure LDAP, secure connectivity with Active Directory on premises in a way that you can move forward with the creation of cloud resources in the cloud. You don't want to have another authentication system in cloud. You don't want to give your user multiple accounts and multiple services. Leverage your existing authentication mechanism, which typically is based on Active Directory, in G Suite as well, in GCP as well, and allow the connectivity with there. Connecting with Active Directory is, in fact, is native in GCP. Our solution uses Google Cloud Directory Sync, which is effectively a small application running on premises that connects and keeps in sync user list on Active Directory with the user list in cloud. And then you can map, effectively, using Samuel, map the permissions of users on premises with the permissions in cloud. So you can annotate a user on-prem saying this user in Active Directory has access to this role in cloud, and when this user goes to cloud, can assume only the role, so can access the user, and you can start enforcing advanced authentication credentials with MFA. We can see here that pretty much we start to break down authentication and authorization. So we break down authentication because authentication moves from a place in which we have them, which we have all together, into a place in which authentication stays with cloud identity, and the permissions are then allow authorization for accessing the resources. And as I said, there's a synchronization between on-premise and cloud. There are quite a few ways. When looking at this, you can ensure that each one of your users have access to the right level of resources in the cloud and have access to the right level of permissions in the cloud. You do this by creating different type of roles in GCP. You can create primitive roles that are effectively deprecated and should not be used even if they're still available. You have then custom roles, and then you have predefined roles. So predefined roles are what we usually you start with, are roles that are provisioned by GCP itself that allow you to get access to resources in a granular way. You can create a role that says, my security team can only read data, my development team can read and write, my InfoSec team, my database team can only connect to database, can only provision databases. So it can become really, really, really granular with this. These policies are very powerful. I can also create exceptions in the policies. I can say nobody can connect to this database except for the database team based in the team in Czech Republic, or database team that has this permission. I can then become even more granular. I can say you can access everything except for that, except for the other side. So you can move around a lot with this and having a lot of different levels of permissions. And IAM is the way in which you get authentication with this. One of the big challenges when looking at Google Cloud adoption, GCP adoption, is to look at making sure that you're following the best practices. Making sure you're following best practices is super challenging. So how am I sure that what I'm doing is correct? How am I sure that I can? Sometimes I'm be required to delete service accounts. Should I do that? Should I not do that? Should I manage G Suite super admin roles? So it's important for you to make sure that you're compliant with the standards. You want to follow best practices. There's a number of best practices available in the industry. Some of them are called CIS benchmark, NIST, NIST, cybersecurity framework. So you can compare your cloud adoption with a set of these best practices, ensuring that you're doing the right thing according to the industry standard. It's very important as well when it comes down to talk with the regulator, the auditors, saying the auditor will ask you, why did you do that? Why did you delete a service account? The answer is because the best practice says so, right? Instead of, this allows you to disambiguate problems with auditors and controls. Okay, networking. So networking is a very exciting section for me. I'm a huge fan of networking. I really love it. Let's take a look at this together. So networking in AWS in GCP really boils down to three concerns. We're looking at shared VPC, how we manage DNS, and how we manage security. So effectively, it is pretty much how we're going to model our network, how we're going to worry about name resolution, and now we're going to worry about security. What we typically see is that we're looking at a shared VPC. Shared VPC is a way to ensure that your network team is in charge, is controlling your host project, and you effectively retaining control of the core of the network, and then you allow your different development teams to get access to a subnet effectively. It is a bit brutal, my explanation, but the idea is that you have a host project that will contain the core of the network. The host project will be managed by your network team that can have an IP address management solution, can implement policies, can control things. And then this host network to the host network, you can connect with a number of service projects, and each one of the service projects can then connect to the network. This allows your network team to retain ownership of the network as a whole, but also gives your development teams freedom to do what they want in their small subset of the network. It allows you to implement firewall policies as well that are centrally controlled and cannot be advocated by development teams. You don't want them to have access to too much, right? We can look here at a bit of a deep dive on the implementation of shared VPC and how it operates. You can see here how shared VPC operates. There's some complexity in here. The idea, as I said, is that there is a different levels in which this operates. Sometimes you have one shared VPC for the entire company. Not usually the case, but possible, especially for mid-sized companies. For very large companies, you will have multiple shared VPC. They are typically connected with security tiers. So you have a standard, secure, high secure, standard, secure, restricted. And each one of the shared VPC is then interconnected somehow to support cross-pillar communication. But the idea is that each one of the shared services VPC allows connectivity across the environment. DNS as well is a topic that has been evolving massively in the past year. So I was a client only last year, and we were struggling with DNS there because we had some very complex DNS requirements. They had a custom DNS server they were developing in-house, and they had to integrate this with GCP, which was a bit of a challenge for sure, because this custom DNS server was not really following the standard DNS practice. It was not really authoritative in the way in which it should have been. So this has evolved. We're lucky because it's recently evolved, and now we can have DNS peering. We can start forward requests, so we can have a proper DNS in cloud that allows you to either resolve cloud resources with Cloud DNS, or allows you to go to on-prem, go to the internet, and start trying to resolve resources back and forth. The important thing is you need to make sure that you have a hub and spoke model in which different projects are doing DNS correctly. You still want to have one core project that is authoritative for the zone, and then you want to have service projects that instead are either authoritative for their own subset of the zone, and or they are simply using the central DNS solution. And then we're looking at firewalls. We're looking at networking. So firewalls, there are different level of firewalls in GCP. There are a lot of different types of firewalls, in fact. Default is usually where the usual denial, the implied rule, and you can have a lot of different rules that can target a specific machine, a specific service, specific subset of the network. This can become really, really complex. It's really granular, really powerful. You have, compared to what you do on-prem, in which you typically tag CIDR blocks, you tag IP ranges, and you say this IP can connect to that IP. What you do in cloud, you can start saying that resource can connect to that resource by virtue of their service account. So you start moving things one level up. You're not allowing one subnet to the other subnet. You're allowing specific resource with a specific identity to talk with a resource with a different identity. It's a very powerful concept. As well as the VPC service control, which are a perimeter. And so is a way in GCP to implement perimeter security. It's a bit of a controversial way because it blocks you from leveraging some other VPC services. So GCP services, you want to double check that for sure, but it's important to do. And then we're looking at connectivity options. This is another core thing. So most companies will connect their on-premises solution to cloud. They start by leveraging the VPN. So they connect with the VPN, but then they realize VPN is not secure as they want to, it's not as fast as they want to, it's not as reliable as they want to. So they end up using dedicated interconnect. They end up using custom solutions that allow with a lease line to connect their on-premises with their cloud and transit to the internet that way. VPN is the way in which you start. All companies are seeing start with VPN, then you move to higher throughput, higher bandwidth, dedicated interconnect, lease line between AWS, between GCP and on-prem. And then for the largest companies that operate wide area networks, global wide area networks, you can have peering with GCP as well. This is typically something that very few companies will have in the world, typically telcos or very, very large companies. So I would say that 99% of the enterprises we work with, the size we work with, they are using either dedicated interconnect or partner interconnect. It's a bit of a slightly difference there, but it's a lease line. VPN to start, and then you move up the chain. How you do that, once again, is pretty much standard side-to-side connectivity with BGP. Layer 2 connectivity, you can be really fast. You can get up to 210 gigabits per second links. To 100 gigabits per second links, which is really powerful. The other cloud providers will not let you be as fast, and you have different level of SLAs as well. So something to keep in mind for sure. Start with VPN, HA VPN, move to interconnect as soon as possible is the way in which you want to go. And then zero trust networking. So this is really a brief session, but to remind you of something, we said, okay, so we're using G Suite identity to connect to our resources in the cloud. How do we make sure that they are secure, they are compliant? Well, the way in which we do that is that we typically adopt perimeter security. So we typically adopt, we say the laptop of this employee at home needs to connect to GCP, needs to connect to our network in GCP, so we give them a VPN, we allow them to connect. This is one way of doing it. It's a traditional way of doing it. It's perimeter-based. Over time, I realized the perimeter-based is a bit of a problem because it does not protect you once you're inside the perimeter. This is not really a form of in-depth, it's a form of control at the boundary, but if you're inside, you're inside. It's the root of also most of the problems, right, that we see in networking today. So security problems. So with GCP, you can start moving to a different place. You can start to authorize flow by flow. Instead of authorizing the entire subnet blocks, the entire communication, you allow flow by flow. And you do this by not only using the IP address of the source, but also by using the identity of the source. So if you're using cloud identity, if you're using this, you're using what is called identity-aware proxy, you can start opening up resources that are deployed inside your GCP network to users outside or machines outside, and these users will authenticate with their G Suite account. They will need to have the right MacBook with them, and they will need to be perhaps in the usual IP addresses, right? So now you're moving from a place in which you have, oh, if I just have the right IP address, I can connect, to a place in which if I have the right IP address, as well as I need to have the right IP address, as well as the right machine, as well as I have a machine learning algorithm that will check whether my connection is high risk. If I'm mostly based in Russia and I have a connectivity from Brazil suddenly under my G Suite name, that's a security risk. It's unusual, so that will be flagged. Which means that we're starting to increase our security posture. We're going up the chain, and we're using cloud-native services to do it. Identity-aware proxy is a core differentiator that GCP has against other cloud providers that do not provide the same level of security and controls. And we call is detective controls about this, and allow us integration with SIEM as well. GCP offers also features to control the data. So we want to make sure that we don't have data leaks. So we have features that allow the enterprise to control where data stays. We have data loss prevention APIs with the security team, reviewing all the buckets in the company, and then checking whether they are, we have some data we didn't know about somewhere. So it's a way of controlling the access to data. Secrets management as well. It's a very important topic as well. So typically we see companies struggling with this a lot. We see companies that need to have a way to ensure that all the applications they have deployed in the cloud are making use of secrets in the right way. They want to make sure that these applications in the cloud are they have access to databases, they have access to external APIs in the right way. This typically ends up in being project sprawl. So some application will do something, other application will do something else, a third application will do something else. GCP offers a cloud-native solution called Secrets Manager that is commonly adopted to solve the problem of secrets management. So you can start having a security team that puts your secret folder level, and then the secret can trickle down and be used by different teams that perhaps do not have direct access to the secret, but their application can. You can have separation of duties in which you have one team that writes a code that cannot read the secret, and then you have a security team that can write and read the secret, and then the application itself will consume the secrets once in cloud and is the only thing that can do it. This connects as well with key management in GCP, which is a common problem. In encryption, you have a lot of ways to do encryption. GCP is encrypted by default in most services. We recommend using customer managed encrypted keys, so CMEK. These keys are the keys that we want to be using in all our services. They can be connected with an HSM where appropriate as well, something we did in the past. Definitely a valid solution for sure, and allows us to have automated management of encryption, re-encryption, and key rotation as well. Okay, logging. So logging, once again, is a significant concern. We want to make sure that the entire entire state is using the right level of logging, both at the application level, at the platform level, at the cloud service level. We usually use Stackdriver, which is a cloud-native solution offered by GCP. Stackdriver is a very complex service that allows for monitoring, logging, performance, and multi-cloud access. So you can have Stackdriver controlling your resources deployed on AWS, you can have Stackdriver monitoring your resources deployed on premises, and collecting metrics and logs from those resources. Very important, very powerful way for Stackdriver to be used. We use Stackdriver to collect all the logs of both the platform, as well as the projects, as well as the resources, and then we send these logs to a centralized storage. We don't store the logs in the projects themselves, or maybe we do that temporarily, but if for long-term storage, they go to their own bucket, they go to their own project, and we do this in a compliant way. So we usually create a dedicated project called logging, where all we have our organization sync, where all our logs are sent from all the application and all the projects. As a platform team, when you deploy, when you create a project for your applications teams, this project will contain all the information about logging and will already contain the configuration to send the logs to a centralized logging account. This logging account is then typically connected to a SIEM. So this logging account is connected to a security system on premises managed by your security team or by a platform team as well. And GCP natively supports a number of these services such as Splunk, Elasticsearch, Sumo Logic, RSI. There's a number of them. It's very easy to do the configuration. The configuration is done through PubSub. The configuration is done through a messaging system, which is pretty standard. And we're using cloud logging for everything. Logging is important as well from a security perspective. So if you have a security risk, if you have a change in the security posture of one of our teams, we want to receive an alert. We want to receive a notification that tells us this is where we are with that. Okay, FinOps and billing. So when looking at FinOps, we have a common concern. You will speak with your CFO in the company. The CFO will be like, yeah, but how do we really make sure that we are charging our projects in the right way? How do we make sure that each one of our teams that now belongs to different business units that have different budgets, they are budgeted in the right way? With GCP and with our solution, which is what everybody pretty much does, we create billing accounts. Billing accounts is a way of consolidating the access to financial data. So we have a billing account that pays for all the different projects. And they all go together typically. Most companies will have one billing account per currency. So if you have a very large enterprise that has a presence in Europe and is paying with euros, you will have a billing account in euros, and then as a presence in the US, this will be a billing account in US dollars. And they all get together and they get consolidated. We can break down, we can be really, really detailed. We can, when creating our projects, we can break down access and cost to each one of these projects. So we can see how much each one of these projects is spending. We can set up budgets. We can set up notifications as well. We can set up alerts on these budgets. If I see that fast for the spend of the project X is going above what I expected to spend, above the budget, I can get a notification to both them, as well as a notification to the developers and the finance team. We can all control this. I can also set up this in a different way. So right now, you see that we have a single tenant project. We have a project that is assigned to a team, but I can have one project assigned to multiple teams, each one of them creating their own resources in the same project, and I can itemize the bill by resource type. So I can say, okay, I want to make sure that I know exactly, given different resources, how much each team within the same project is spending. It's really flexible and it's really powerful. Services are changing this way called cloud billing has been announced a few days ago. Looking at this is really interesting the way in which this is evolving. There's another place in which GCP is spearheading and is ahead of the competition with budgets, with alerts in place, with billing based on resource names. Like this is really, really powerful. Others don't do the same thing. And in the end, we have for our last section now, operating model. So this is the last part of the talk. We looked at a number of concerns for the creation of a platform in cloud. We looked at networking, security, secrets, logging, authentication, resource deployment. We said we need to build these projects. And this is where I would say most companies get to. Most companies that adopt cloud get to this. They get to the creation of a form of technical solution. Maybe not the perfect one, but companies get there. What most companies fail, and we see this unfortunately, is the fact that companies struggle with the operating model, struggle with changing the way in which the company operates to leverage the power of cloud. In a lot of companies, the naive way of adopting cloud is a way in which you're effectively taking the cloud onto taking the cloud as if it was data center. So you're building, we say, a data center in cloud. You're adopting the same practices you have in the data center onto GCP. This is a very big problem because it means that you're not leveraging the value of cloud. Your teams are not becoming faster. They're just using different tools. And this is a problem, right? There's no value in it. You need to adopt a different operating model. The operating model of cloud fits within the operating model of the enterprise and is a function of the strategy of the company. Company usually looks at why they're leveraging cloud, the cloud vision itself. Cloud vision is led by your executive team and say, we need to use cloud for this reason. Maybe we're looking at cost reduction. Maybe we're looking at increasing velocity. Maybe we're looking at a different compliance posture. Whatever is the reason, let's look at why we're leveraging cloud. And from that, establish and change the processes, change the operating building blocks and the capabilities for the best use of the cloud. I will give you an example of this because I tell you how complex sometimes this is. So historically, we were working with an enterprise in which historically this enterprise was bringing up a lot of new projects. Each one of these projects was then defined in a design document, and the design document was sent to an architectural approval board. The architectural approval board would spend weeks discussing a Word document and say, yes, it's correct, no, it's wrong, this is correct, maybe it's not wrong, maybe it's right, maybe it's wrong. And then the next team comes in, and then the same thing happens, and then the third thing comes in, and the third thing happens. When they go to cloud, they have done the same thing. They effectively took the process they had on premises, they mapped that process to the cloud. This is a problem, right? Because it means that then you're not leveraging the velocity of cloud, because with cloud, you can change things. How do you do that? Well, instead of sending your architectural approval board a Word document, send your architectural approval board your Terraform code and tell them, this is my Terraform code. Do you approve it or not? So we're doing compliance as code. If the architectural approval board says, yes, I approve your Terraform code, that means that all your teams, the future teams, can now reuse your Terraform code, and they don't need to go back to the architectural approval board. They can be faster. So you automated compliance, okay? This is a very important process, very important step. Cloud lets you do that. High-level automation translates into a change of the business process that enables velocity. If you don't change the business process and you just change the tool, you don't get velocity. If you replace Ansible on-prem with Terraform in GCP, in the cloud, you will not get velocity. You will just get a different tool. If you want to get velocity, you need to change the architectural approval board. This is where companies struggle. Companies struggle because it's much easier to change a tool because the intention behind this is much harder to change a process that can touch politics within the company. So you need to look at your cloud organization. You want to look at how your teams are organized. How are you going to structure this cloud adoption? Which technologies are we going to use? And how are we going to govern that? How are we going to ensure that the governance is done correctly? So the solution to this is a need to transition to a shared responsibility model. When you have your data center on premises, you're in charge of the whole thing. You're in charge of security of the walls, of the data center. You're in charge of security of the cage in which your computers are. You're in charge of security of the laptops, of the computers. You're in charge of security of the network, security of your application, everything. And you have different teams within the same company looking at this. Typically, there's an operations team that look at 80% of this. When you move to cloud, you start offloading some of the responsibilities onto the cloud provider. Depending on the service that you use, you offload more or less responsibility. If you're running a database onto a VM, you offload personal responsibility because your cloud provider will look after your virtual walls, will look after the underlying hardware, you will look after VM and database server. If you're using a tool like Cloud SQL, your cloud provider is a higher level managed tools. Your cloud provider will look after not only the application itself, not only the OS, but also database itself. It's a big change. It means that you are not worrying about that. You're handing over responsibility to your cloud provider that you're paying for. It's a very important point. It makes no sense to use Cloud SQL and pay for Cloud SQL and then treat Cloud SQL as your database on premises. If you have a development team that needs to provision Cloud SQL resources, you don't want this development team to having to go to your database team and having your database team again creating a Cloud SQL instance that then is handed over to your database, to your development team, right? What you want to have is to have autonomy that enables your development team to create and destroy its own databases effectively, and you want to have instead your database teams to define the policies and the process in the company to create databases. This is a shift. We're moving from an active role of the supporting function into a consultative role. This is why we say we move from fully operations team to a tiered system in which we have cloud provider in charge of the subset of the underlying components, compute, storage, database, and network. We have different level of cloud services in charge of platform. This is your platform team. Your platform team will look after compliance of the projects, will look after networking of the projects, will look after incident resolution, will look after data backup and recovery, and the platform will be ready. In certain companies, your platform team will be in charge of your container running solution, container scheduler, Kubernetes typically. In other companies, you will hand this over to your consumer team because those consumer teams are the ones that are deploying code. You want them to be as autonomous as possible. You really want to minimize the number of interactions that your development team needs to have to get to production. Automate as much as possible for development teams to be as fast as possible. Ensure compliance and security, not through gates, but through automation that gets defined by your platform team. Platform team, which is made of database experts, network experts, security experts. They define policies and practices. They need to have this mandate to change, and then your development team will become faster at developing and creating code. We're moving from a place in which we have a centralized corporate data governance into a place in which we have decentralization. Decentralization comes with security risk, comes with duplication risk, comes with, if everybody does what they want, how do you make sure that I'm compliant and secure? And we said, we don't do that by gating the freedom of the teams, but we do that by defining policies that allow the team to operate within the constraints set by the company. This is the key change, the key differentiation in the definition of the operating model. Okay, that was the end of my talk. I hope you liked it and you enjoyed it. I think it's time for some questions now.
Yeah, I think that's. Thank you for your talk, Federico. So we have some questions in our Telegram chat. The first one: why do you prefer Terraform before Deployment Manager? So why you use Terraform?
Oh, that's a very good question. That's a very good question. So Deployment Manager has been the historical way for deploying resources on GCP. Terraform as has evolved in more recent times. Terraform enables two things. Terraform on one side enables you to use the same language to describe resources across cloud providers. So I can use the same language, the HCL, the Terraform language, to deploy resources on GCP, AWS, and Azure. So I can be a bit more multi-cloud in the way in which I deploy resources. But also, Terraform holds a state. So I can use Terraform to connect with all the other compliance and security tools that can analyze the state. It can check CI/CD pipelines with Terraform that the deployment manager doesn't use. I have to admit, in talking with, I don't work for Google, but like in talking with all the GCP engineers that I spoken with, people working for Google, the general perception is that we're deprecating the use of deployment manager towards Terraform, and Google is pushing a lot this. In fact, if you're looking on GitHub, there is a repo on the Google Cloud Platform handle with Terraform modules. This repo contains a lot of GCP modules that can be reused in your projects, and is commonly used, and is really backed by GCP. So deployment manager is kind of phasing out. My 2 cents on this.
Okay, thanks. Before the next question, I would like to remember that you could write your questions to the Telegram chat, and Federico will answer to it. So the next question is, so do you agree with the statement that GCP API is poor enough in some way, and that's even more poorly documented? I think that it's about comparison between GCP and other cloud providers. And our attendee said that for him, he's stuck with a situation where he cannot create Cloud SQL instance connected to the specified VPC network because GCP API didn't provide such option. And that's right, because we use GCP Cloud 2, and we know that all Cloud SQL instances are created in a special private network, and if your instance is not public, you could not access to it from any place instead of the main VPC. So for this instance. So the main question is that do you think that do you think that GCP API is more is poorly documented than others, and so?
So that's a good question. I will say so. I will say that, yeah, I mean, the maturity that AWS and Azure have is higher, my perspective, than GCP's ones at the moment. But GCP has something they don't have. GCP has a different level of stability in the APIs. So you will see that AWS and Azure will promote to GA, the general availability, services that are not as mature as you want them to be. Typically, when we see AWS announcing a service, we all say, great service, but wait for a few months because I'm sure there will be bugs that will need to be cleaned. In fact, the saying in the industry that says, I think it's something, Google's beta is AWS GA, right? So Google is way more reliable on this. But yes, the maturity is very different, as well as the adoption. On the Cloud SQL question that was coming up. So this is such a common question that I see coming up and talking with companies as well. So the reason being, I think, is because Cloud SQL differs from RDS. So the way in which you deploy resources in AWS is that you create this database instance in your own network, and it's available, it's there as a private IP address. It's just part of the network. In Google, this changes. You deploy your Cloud SQL instance in a shared VPC that then is paired with your VPC, right? If you're doing private network, which means that Google owns this very big VPC with all the Cloud SQL instances, pretty much, and then you can peer to that VPC with your network. Right? This introduces limits for sure. It introduces limits, especially when it comes down to transit. So yeah, if you have a Cloud SQL instance that you can connect this Cloud SQL instance with your private network, yes, you can. The UI perhaps is not perfect on this. I've seen UI failing a few times. For reach out to support if you want to, but you can't do it. Then you connect to your private network. But because you have network A, network B, if you have a VPN on the other side and network B doesn't do transit, you cannot reach the private instance and hop into it. This is why we see use Cloud SQL Proxy being used a lot. Cloud SQL Proxy is a way for you to effectively jump into database instance. So the solution there is try to use private SQL whenever available. Consider Cloud SQL Proxy to jump onto the instance from your location. Because unfortunately, the way in which a shared VPC exists is a way in which you don't do transit, and so you cannot get to the instance directly.
Thank you. So yeah, we use Cloud SQL Proxy too, because we think that's the only way to make your instance accessible from another VPC network. So we have no other questions in the chat. So I ask you. So yeah, about your talk. So I saw your talk first time, so I do not see I did not see it before. So I have a question. So you have a very top level overview of different cloud GCP components. Yes, so it's like projects, organizations, billing, and so on. Do you have a piece of to us what tools you recommend to bootstrap maybe medium projects, not for very large organizations, and from what point, for example, so we started as a small startup. Yes, so we still a startup, but we grows up. And we faced with typical problems, because we started with one project for several developers, and then we do not divide projects for maybe some for each team in our organization, because in sometimes we divided on the several teams. So for maybe for medium organizations, for like us, like my organization, what tooling you could advise to bootstrap maybe new projects, or to migrate current state, yeah, maybe not well defined, yes, to gold one. So
that's a good question. Okay. So if you are to bootstrap a medium-sized company, I would say starting small, go online, get Google's, go on Google GitHub profile, download their Terraform module, and start with that one. Is the link is in my slides, is also Google search away. Can go there and download that one. And then you will start from that place. So you have a place to start. You will need to customize it for sure. You will go with that. Where is the limit with that? That is, I don't think is in the number of developers, but is a number of security constraints you will face. If you have a security team, a security team will have concerns. If you have an auditing team, and your auditing team will need to review that. If you start having external controls onto your platform, then you need to have a level of security you may not have in place. If you have a distributed team, where you have a distributed company with one team in one place and one team in the other, there's a common problem. There's a common problem, and you probably want to have some form of control around that. This is why you start having that. Now, in my experience, though, we were deployed in a number of projects, even with large enterprises that had dozens of different projects on GCP, each one with their own security posture. We were asked, okay, but how do we move all of this into a standardized way? Right? In that case, what we did was starting from the same organization, top level structure, and creating completely new folders, These new folders are created with the right level of security, controls, the right level of logging, the right level of billing policies, all is correct there. Then you start moving one project after the other into the new folders. This can present challenges because some projects will come with their own networking, with their own state. So moving those projects can incur downtime, can incur challenges. You also want to do, one thing I've learned, you also want to do a IP address management IPAM solution. You want to have an IPAM solution that tells you, I have some IP addresses here, some CIDR blocks here, some CIDR blocks there, some CIDR blocks on-prem, and I want to kind of like connect them, right? That's really important. But still, I think that you can start with the creation of new folders and moving them one after the other, after the other, after the other. These folders are not as big sometimes as you want them to be, because sometimes you have to move one project after the other, after the other. But and it's a bit slow, but it's a way to go. New folders under the same org with different permissions, move one project after the other, after the other, after the other. At the end, you will have finished, strangle them down, strangle the old folders.
Yeah, thank you for your answers and advices.
Federico,
So I think that
Alexander?
was the last question.
Yep. Thanks, Alexander, for transmitting all the questions and coming up with your own. Federico, thanks a lot for the great talk. And there is one notice I'd like to mention from our Telegram chat, that the presentation was like too small for the small screen. So for the next time, maybe have like bigger fonts. And if it's possible to share it, there are people who are interested in it. If it's not, it's okay. And yeah, once again, thanks a lot for awesome talk and all the questions. And
No worries. Thank you for having me.
you're absolutely welcome. Come again. And if you don't mind, I do have one small question from my side. And I found that Cantina does have its own GitHub account, and there are some projects there. But how active are you involved in open source development, and what is your like usage of it, and what is the like feedback? Very short.
So we are no, sure. We're using continuously using open source. Is using open source a lot, but because we're working with this large enterprises, most of the work that we've done cannot be open source because of the contractual agreements we have with them. We create something on our own, which is IP of the company that we try to publish as well as much as possible. It is possible that our solution will become open source at some point as well. Is a point of discussion, I think. But yeah, we're trying to do as much as we can. Unfortunately, some of the clients we work with constrain our ability of publishing solutions on our GitHub profile.
It's a great answer. Thanks a lot. And if
Thank
you
you.
have anything else to share, please do. But otherwise, I think it's the end of this particular talk, and we will move on to the Russian part and the ending of today's session. Okay, thanks a lot, everyone. Nice to see you here and have you here, and you're welcome. My pleasure.